Alright, good afternoon, y'all. Today, this is the fourth computer science multiple choice session I'll be doing. Most likely it'll be the last one for the 2020 season. And it's because, well, there's a student who sent me a set of questions that I didn't do on the previous 3 videos. So because this person worked so hard, I'm going to do all the questions that they ask, and more than likely we'll cover a lot of things, almost every question that you would possibly see. But as usual, before we start, this is my website, makeITsimpleTT.com. My name is Mr. Charles. I teach everything IT and ComSci related, so you could get CSEC IT and ComSci and IT. So I have classes every week, and the classes could go from with IA or without IA, and trust me, if you like the videos I see on your channel, you get twice as much effort in the actual class. So makeITsimpleTT.com, check that out, which is here, and you will see tuition services in whichever class you want to go to sign up for. You just go and click fill out the form. When you click fill out the form, it will give you the ability to fill out the form. Send that information and I'll get you all on the inside. Good. So let's get down to business. I don't know how to pronounce the name Jovian, but I'll say Jovian. I almost said Jovain, but nah, close enough. I wasn't there at christening. Alright, so we're jumping straight into it. Question 1. Well, first question. Some of them will be all blurry here because this is how I got them. This is how they were sent to me. Alright, so this first question says the following. I can't remember the first one. Jovian, yep. Alright, so consider the following 3 algorithms which will print a sequence of numbers. A sequence of numbers will basically be like 1, 2, 3, 4, 5, meaning they're going in order, right? So let's look at this one. This one, x starting off at 4 while x is less than 5. So once x starts at 4, that means this loop is just going to run once, because it will run the first time, it will print the 4, but then after that x is equal to x plus 1 will change it to 5. And once it changes to 5, it will be 5 is less than 5. 5 is not less than 5, so therefore this is not going to print a sequence, it's only going to print a 4, right? Next one, x is equal to 3, while x is less than 4, so this will be 3 less than 4. It will carry up the value of x by 1, so x will end up changing to 4, and then it will print out that 4. So this one only going to print out the number 4. This one here starts x as 4, and it says repeat. Print the value of x, so it will print the 4. So it'll print out 4 first, then it will say x is equal to x plus 1, which will change the x to 5. So then we'll ask ourselves is until 5 is greater than 5, but because x is not greater than 5, because there's only 5, we're going to run it a second time, so it will actually print the 5. Then this x will change to 6, and then when it changes to 6, 6 is greater than 5, therefore it will stop. So the sequence of numbers I get is 4, 5. Yeah. I think I remember this question, and this question have a problem. It's not logical. The only one that will print a sequence of numbers will be this one. Will print 4, 5. This one here, x starts at 4, it will print the 4, then it will carry up x by 1, and it says while 5 is less than 5, 5 is not less than 5, so therefore it won't do the while loop. This one here, while 3 is less than 4, it will carry up the 1 to 4, print the 4, and then 4 is not less than 4. Yeah, so this question is one of the questions that have an error. I mean, these days, because of the amount of multiple choice that we're doing, are bouncing up real errors in papers, the only question here that I'm going to print a sequence of numbers is this. This one is going to print 4, 5. So there is no actual answer here. So I could understand why this one was confusing to you, because it actually makes no sense. Oh, sorry, prints the same sequence of numbers. I didn't see the word same. Yeah, there goes me again. Alright, so if it prints the same sequence of numbers, only 1 and 2 will print the same thing. So the answer is A. The question does not have an error. I just read it wrongly, which I tend to do at times, but I'm human, just like you. Just like you. Alright, so A is the answer for that one. Any questions? Nope. Good. Next one. Let's see. Alright, given the variable num declared as follows, double num, which of the following statements will correctly read a value entered? Alright, double is similar to float. So to do a decimal, you have either float, or double. Float will give you like, and I can't remember, 6 decimal places. Double will give you twice that, so double will give you like 12 decimal places. To read a float, you had to use %f. To read a double, you had to use %lf, right? Because it's like long float. So when you read any float, you're going to use %lf and num. So the answer will be D. As soon as you have a question or you don't understand, let me know. Because I don't want to take too long waiting for you all to ask a question if you understand. Alright, this one real blurry because it looked like it was taken off a picture of a monitor. So I'll try to make it as clear as possible. But you know, it will still be a little blurry. Alright, the following segment of code. Whoa, my eyes. Alright. Item 43 refers to the following segment of code. Int mark, scanf, %d mark, if mark is greater than or equal to 50, print pass, mark is equal to mark minus 10, if mark is less than 50, print fail. Which of the following string if the user enters 55 for the mark? So if they enter 55, it's going to check to see if mark is greater than or equal to 50. 55 is greater than or equal to 50, which is correct. So it's going to print pass, and then mark is equal to mark minus 10, so that'll be 55 minus 10, which will give you 45. And then it has a next if now to check to see if mark is less than 50. So you want to check to see if 45 is less than 50, which is true. So then it's going to print fail. Yes, so you're going to print pass and fail. So the output will be pass, fail. Or no, A will be correct also, because if you do have the brackets here for mark greater than 50, it will give you a syntax error. But I'm not too sure if there's curly brackets or normal brackets. I can't see properly. It's looking real blurry. It looks like it's curly brackets. The code segment contains a syntax error since the two statements in the if are not enclosed in braces. Oh, they mean curly brackets here. Yeah, it's supposed to have curly brackets there and there. Alright, the problem with this, I can see why I only have a problem with this, because there is actually a syntax error because there is no bracket here. But that's not what they're asking in part A. Part A, they basically asking if you will get a syntax error because you don't have curly brackets here. But you won't get a syntax error because it will just do this part of the if will do this one first, then this mark here will be seen as sequential. So it will just do whatever comes after the if. This is not based on if the statement is true. The only thing that the if statement going to do is this pass part here. And then you have if mark is less than 45. So actually you won't have a syntax error, so the output will be pass fail. But you will get a syntax error because you don't have the normal brackets there first by mark greater than or equal to 50. But that's just a case of them trying to be too cute. So it's cool. Right, any questions there? No. Alright, next one. This one is straight. Look, this one looks like a theory question. In the implementation and review stage of the problem solving process, implementation involves the installation of software, analysis of the problem, evaluation of alternative solutions, writing the algorithms. Implementation will be installing the software. Because after you code it and after you you go through all the coding and testing to make sure the software working properly, then to implement it to see if it's working in real life, you'll have to install the software on live computers or the production stage or something like that. Alright, next one. This one is a blurry one. I apologize. I just got these questions, right? Because I just reward any hard work of a student for picking out all the hard questions you have to do. Alright, the following refers to a program with low-level instructions. Load contents of X into the accumulator. Add the contents to the accumulator register, store the contents in X. Right, anytime using the accumulator, the instruction format that you're using is one addressing, because one addressing will be like add X and then it will just use the accumulator for everything. If it was two address, it would be add X to B or something. So these would be two addresses because you have a register for X and a register for B. But if you're using the accumulator is like a place where it's gather all the calculations. So your answer here is B, which is one address. Next, item 20 refers to the following algorithm. Let's see. Alright. 20 refers to the following algorithm. If num is equal to 5, while n is equal to 1, alright, okay, so n is equal to 1. So 1 will be less than 5, that will be true, good. Num is equal to num plus n. That means you're going to add 5 plus 1. So num is equal to 6. And then n is equal to n plus 2, so n will be end up equal to 3. Print num, so you're going to get 6, 3. Oh no, so it'll print the 6 first, yeah. So it'll print the 6, and then we're going to say 3 is less than 5. So once 3 is less than 5, you're going to have 3 plus the number. Number was 6 before. So that will be 6 plus 3, which will give you 9. So it will print 9. So you're going to get 6 and 9 being printed. Yeah. Because, yeah, that was basically 6, 9. 6, 9 is the answer. Because the first time the loop runs, you'll get 6. Safe. Alright, next. Whoosh. This one kind of a long way. Let's see. Alright. Let's see if I can fit this on the whole page here. Alright. It will be small, but I'll read it out for y'all. The following is an algorithm which counts and displays the number of votes obtained by 10 candidates in an election. Each vote is input as a number between 1 and 10. So that means they could enter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Corresponding to one of the candidates. Data are terminated by 0. Cool. So we want to keep track of the number of votes obtained by 10 candidates. Now, what they're doing here is that they have an array. No, they don't have an array. Is there an array? No, we don't have any array. Okay, right. Why did I think it have an array? I think there's a similar question to this that have an array in it. Alright, so we have for I is... Oh yes, so there is an array because you have X, Y, and Z. Those are the things that you have to put in. Okay. So what we're trying to do is we're trying to fill out this this code with the correct code from here. So before I go to the answers, I want to just fill out the code, right? So the first thing that you're going to have to do is set everything to 0. So you have for I is equal to 0 to 9, begin. What you want to do is set everything to 0, which it will be like ARRI will be equal to 0, right? That will set everything to 0 inside all the arrays. So basically, array is going to have 10 spaces, and you want all of them to be zeros. The thing that you had to keep in mind, however, is that the array starts from 0 to 9. So you have location 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. But the actual voters, the actual candidates will be 1 to 10. So this is actually candidate 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9, 10. So that's the trick here. We're trying to make sure that they coincide. So the first part, X, is definitely just to set everything to 0. So we could start by narrowing it down to, alright, it's going to be between C and D for sure, because we need to fill up all the locations as 0. That's always the smartest thing to do, right? Next thing we want to do is read the vote, and while vote is not 0, begin, right? So we're saying, we're trying to fill out the code, while vote is not equal to 0, begin. What do we want to do? We want to check to see if the vote is equal to no. Based on how they're trying to do it, they just want to put it straight in the array. So we have to figure out between which one of these is the best one. So if we say ARR vote minus 1 is equal to ARR vote minus 1 plus 1. What does this say? This means the vote that the person put in, let's say the person put in the vote of candidate number 1. That means at location 0, I want to carry up the number of location 0 by 1. So this is going to carry up location 0, which is currently at 0, because this is vote minus 1, which is 1, right? So that will end up becoming 0. So at location 0, I want to add 1. So that means this candidate here is going to go up by 1, because that vote is correct. Now we look at the other option. The other option is, this is that one. The other option is this one, which is ARR vote is equal to ARR vote minus 1 plus 1. So let's see what will happen here. Let's say the person votes for candidate number 1. What's going to happen, because they vote for candidate number 1, you are going to be storing this in ARR1. But based on how we see it here, location number 1 is not candidate 1. Location number 1 is actually candidate 2. Location 0 is really candidate 1. So that's why I have to use this one, which is the vote minus 1, because the minus 1 here is going to make sure that you store it in the correct place, because this whole thing here is going to get replaced by 0. So what you'll end up having is ARR location 0 is equal to 0 plus 1, so that means it'll go up by 1. And same thing will happen if you vote for candidate number 6. You'll end up having to do it at location 5, because remember, the location and the candidate is what you're really trying to match up. So the answer here will be C. What they're really testing is, do you know the difference between an index and a number? Arrays start from 0, but numbers in normal people terms it starts from 1. So your answer will be C. Next one. Okay, let's see what this one is. Alright, so the following algorithm is going to set number to 1, set counter to 20, if number mod 2 is equal to 1. So mod is really supposed to check to see if you get a remainder. If you get a remainder, that means it's an odd number, right? So we set the counter to 20. Do? Okay, there's a do while, okay. So do. So we're checking the number. Number is 1. 1 mod 2, does it give a remainder of 1? Yes. So therefore it will print the number. So it will print 1, we know that for sure. Increment number by 2, so that means number gonna go up to 3, so we go and change that and check 3. And this will keep going over and over while the number is less than or equal to 20, right? So we're starting with 1, and this increment is going up by 2, so 1, 3, 5, 7, 9, 11, 13, 15, 17, all the odd numbers, 19. Right, now when we reach the 19, now we have to ask ourselves a question. Would it stop at 19 or go to 21? The number, the instruction for go to add by 2 is down here before the while loop increment. So the last thing that will happen is 19 will change to that, right? 19 mod 2 will give you a remainder of 1. Then it will print the 19, and then it will increment the number by 2. When it increments the number by 2, what will happen is that this number here is going to change to 21. And then the condition 21 less than or equal to 20 is not going to be true anymore. So therefore, it will only go up to 19. So it will start, so the answer will be D. Yeah. Good. All right, moving on. $36 now. Let me see. That's all. All right, next question. All right, in A, B, and C, for A is equal to 1, for I is equal to 1, I is less than 5, plus plus. So this going from 1 to 5, so that'll be 1, 2, 3, 4, right? Because it's I less than 5. Ah, damn. Yeah, because it's I less than 5. And that means that we print in A. What's the value of A? 1. So it's 1 multiplied by value of I will be 1. So 1 multiplied by 1 will be the first loop. So the value of a and I. Alright, so on the first loop, I is equal to 1. A will end up becoming 1 because 1 by 1 is 1. On the second loop, I will be 2. So A will be 1 by 2, which will be 2. On the third loop, I will be 3. 2 by 3 is 6. On the fourth loop, I will be 4. And 24 will be the answer there. But wait. What will be the value of A after the execution? Yeah, it will be 24. Because B has nothing to do with anything. If they ask for the value of B, then it will be 24 by 5. But the value of A will just be 24. Because this loop here only goes 4 times. 1, 2, 3, 4. 1 to whatever is less than 5. So you're going to go 1 to 4. Right, answer is 24. Good. Next. Let's see. Going on. Alright. How many lines of output are produced by this code segment? Okay, so we have a value which is 5.6. Then we have our next value which is 3.0. And 5.6, 3.0, and then 1. Alright, so while product is less than 50, so we have num1, we have num2, we have product. Right. So num1 5.6, num2 3.0, product is 1.0. Cool. While product is less than 50, is product less than 50? Yes, good. So we want to print the new product is something. %G. Why do I have %G? Hey, something's I just not gonna question anymore. %G, I never see that before. Okay. Probably is like a data type. Alright, so it's going to print the product is 1. So this line here is definitely going to be a print. Good. Next time now is product is equal to product by num2. So that's 1 multiplied by 3. So product is going to become 3.0. Is it less than 50? Yes, so it's going to print this also. Then it's going to be product by num2, which will be 3 by 3, which is 9. And then it will print 9 3s are 27. And then once it hits 27, it will go one more time. No, it wouldn't go again, because then it will be 27 by 3, which will be over the 50. So it's only going to print 4 times. It will reach up to 27. So you're going to print 4 times. So the answer will be C. I hope. I'm going to double check that. It's kind of sketchy. It will print product is 1, multiply. Printing product is 3, multiply. Printing product is 9, multiply. Printing product is 27. Yeah, good. Yeah, 4 times. So number 37. Yeah, that'll be that. Next question is this one, which is kind of like an array. Alright, let me see what's going on here. This one is int I, blah, 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 blah. Alright, so this is an array with 6 places, so it's actually 7 spots. So that's why I have I is equal to 0, I less than 7. That's good. Int num is equal to ARI, so we take in the whatever's inside this here. The 23 is going to go inside number. if num mod 2 is not equal to 0, that means if it's odd, print out the number. So it'll print out all the odd numbers. So if the number odd, it will print, which would be 23 will print first because that's odd, 45 will print here, 27 will print, 34 won't print, 56 won't print, 1 will print, and 92 won't print because they're just looking for all the odd numbers. So do we have that? 23, 45, 27, and 1, yeah. So the answer here will be T. Because the thing is, it's looking for all the odd numbers. Anytime you do the mod, and you're not getting a remainder of 0, not equal to 0 means that you have you have a remainder, and if you have a remainder, that means you're odd. That means you are odd. Okay, next one. Let's go again. Alright, some I, some blah 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 blah. Alright, so we have a sum, we have a I. So we have some, we have a I starts at 4, sum starts at 5, but in this case I is going down, right? Because the minus minus means decrement. So we're going down by 1 each time. So sum is equal to sum plus I is going to be 5 plus 4 will give you 9. Right? So we'll print out 9. Oh no, wait. Yeah, so we have to go through. It's not gonna print on the 9, sorry, just gonna have the 9 there because this here is actually the for loop. This will just be printed at the end. So we're gonna get 9. So I'm gonna go down to 3. So 9 and 3 will be 12. And go down to 2. 12 plus 2 is 14. Then we'll go down to 1. 14 plus 1 is 15. And that is it there because the loop will stop once this reaches to 1 because no, it says for I is greater than 1. Okay, because it says for I is greater than 1, as soon as our loop reaches to, our I reaches to 2, that's when it will stop because the I will never reach to 1 because 1 is not greater than 1. So you're actually going to stop by 14, so you'll get the sum is 14. Yep, that'll be B. Next one. Ooh, I remember this. Yeah, this one has some issues. I had to explain this well. Alright, so for this one here, this is saying close parenthesis is, sorry, what's the error? So if you don't have a parenthesis, that's a bracket, right? Just in case you didn't know, parenthesis means bracket. The value of a wrong type is assigned to a constant. So that's like, instead of putting int, you're supposed to put float, something. At which stage of the compilation errors will A and B detected, right? So A will be detected when you don't have the brackets. That will be, I think it's lexical. No, wrong data type. No, this was syntax and lexical right here. If you do have the brackets, that's a syntax error because brackets will be a rule of the programming language. I could be wrong on this one, because the closeness between lexical and syntax, very close. But wrong data type now, that'll be lexical because a lexical would give you a, if you try to put an integer and you put 3.29, that's not a, That's not a semantic error, because semantic error will be logically, like things that are logically wrong. So my answer for this will be syntax and lexical, because syntax is when you don't follow the rules, which will be the bracket. Lexical will be some sort of meaning that is off. So the integer can't be a decimal. Next one. Let's see. All right. Instance problem here. Yeah, you got syntax error because clearly 10 sum can't be a variable name. The answer is A. Don't even bother to look at anything else. It has no way you can have a variable name that's starting with a number. It will get vexed with you. The compiler will just say, bro, take your time. Take your time. Next. Alright, let's see. Right, so these are 2 questions. Alright, match each item below with one of the components above. Each item may be used once, more than once, or not at all. Which of the components handles x less than 0? That'll be the ALU, so this is A, ALU. Which of the components coordinates the saving of file to saving the file to a drive? That'll be the CU. So that'll be B. So A does mathematical calculations, that's the ALU. B does coordination of inputs and outputs into the CPU. So if saving things to the hard drive, the CU would handle that. Next. Okay, another weird one. Come on, look this up. Whiteboard. Behave yourself. Okay, right. So we have this code here. While, something is equal to 1. I guess it's a I. Yeah. It's kind of weird. I believe there's an I there, right? I hope so. Right. So while I is equal to 1. While I is not equal to 12, do product, okay. Alright, you're calling back the print product, okay. This algorithm best illustrates an example of using what? This is using a test first iteration, because you are testing first here. Testing to see what the value of I is. So that test first. Describe the following terms in best type by command using V and 5. So which of the following terms best describes the type of statement used in the line 5? That is a incremental statement, because you are incrementing that's basically I is equal to I plus 1. So C, incremental statement, that'll be correct there. Afternoon here. Arun. Next one. Did I do this? Okay, no. let's see. So this algorithm says total marks equals 0, total marks, read mark, while mark. So there's a while loop somewhere for a reason. Which of the following programming constructs is using the algorithm above? Is a while loop. So a while loop is an unbounded iteration. Bounded is a for loop. Recursion is what they call a function inside a function, and selection is if. So that's just unbounded, which is a while loop. And there is a follow-up to this question, which is what is the output when the algorithm is executed with the following input values? Alright, so when you put in the numbers 45, 56, 79, 84, minus 1. Alright, let's trace this through. So the end of data is minus 1 and the while mark is not minus 1. So we know for sure that this thing will not stop when we reach minus 1. No questions asked. That's easy to grasp because while mark is not equal to end of data, and they clearly tell us end of data is minus 1. So we just basically gonna add up until we reach minus 1. Yep, because this total marks is equal to total marks plus mark. So we add in 45 plus 56 plus 79 plus 84. I don't know how good your maths is, but I don't think you could go with a calculator in the exam. So 6 and 5 is 11, 5 and 4 is 9, and 1, 10, 101. 101 plus 79 is going to give me 190. Then 190 plus 84 is going to be how much? I add that correctly? 44. Oh, this will be 180. No. 190. And then 190 plus 84. Alright, again, 74. Alright, adding wrong. Oh. It's not working out very well. Nine and 8 is 17. Again, 274. Something wrong. Ow. Alright, let's add this again because let me not take it for granted. Alright, so total marks is equal to total marks plus mark. Both of them starting off at 0. Cool. And we read in these numbers. So 45 plus 56 plus 79 plus 84. Well, this is not making sense. Okay, Google. Add 45 plus 56 plus 79 plus 84.
The answer is 264.
Yay! Alright, so I was adding wrong. I have no idea why, but whatever. No time to waste. Of course, you will add properly when you're in the exam, right? So 264 is the total. So 264 should be in the middle. Not 246. 264. And well, the only thing that I have 264 is that, because we definitely know that while loop not going to continue when you get the minus 1. So the answer is clearly A, but just for argument's sake, let's divide it. 264 divided by how much numbers we got? 1, 2, 3, 4. 264 divided by 4 is equal to 66, which is that. And how many numbers did we get? 4 numbers, right? So your answer is A. Yay! You got to do maths. Where they would have tricked you with this is that you wouldn't have known that the condition end of data is going to stop on minus 1. That's the trick there. Next question is this one. we roll in our answer in all. So after this will be like the ultimate ComSci playlist. There'll be nobody that could ask for more multiple choice questions to be worked out. None. Zero. Alright. Num 0, 1, blah, blah. Right. So num is 1, n is 0. While n is less than 5, so 0 is less than 5, so that means it's going for 0, 1, 2, 3, 4, right? So that means it's running 5 times. Num is equal to num plus n. That means it's going to take the number 1 and add it to the n. So let me put the n, because I'll trace table on the side here. We have n is equal to 0, num is equal to 1. So we add in 1 to the number. So num is going to stay as the first time. Num is going to be 1 plus 0, which is 1. But then n going to go by 2, so n will become 2. Next time it's going to be 2 plus 1, which will be 3. N going to go by 2 again, which will be 4. 4 plus 3 is going to give me 7. And then n going to end up becoming 6, and the loop will stop there because 6 is not less than 5. So my output going to be 1, 3, and 7, because this first num here, I just recorded that because that is what the set num has on top there. So it'll be 1, 3, 7, which will be C. Cool, good. What output is produced by the algorithm if n is initialized to 1 and num is initialized to 5? Well, let's change it. N is initialized to 1 and num starts as 5. So we're going to have means you're going to have 5 plus 1, which will give you 6. 1 going to go up to 3. 6 plus 3, which will give you 9. And then num going to go up to 5. And that will stop right there. So you just get 6, 9, which will give you C. That's just trace table in there. Simple trace table in. What else? What else? Did I do this? Yeah, I do that one already. 23, 45, 27. Okay. Alright, let's do this one now. Let's see. Paste. Alright, so we have what is printed by the code segment above. Well, this code is basically going from 0 to 6, which is 7 times, and it's going to check to see if the number inside here is, I just do this question, I think I just did this question, but we're checking to see if the number is mod 2, if it's 0. So that means we're looking for the even numbers. So we're looking for the even numbers, or the even indexes. Yeah, it's the even indexes because we're using I. I is the index here, so we're looking for 0, 2, 4, and 6, right? So 0 mod 2 will give you a remainder of 0 because nothing will be left. So that means we're going to get the, what is that index here? So we're getting 23, 27, 56, and 92. 23, 27, 57. So you'll get B there because remember there's the index. So we check in 0, 2, 4, and 6. Those are the even numbers. If we change it to number not equal to 0. So now instead of looking at the index, we're looking at the number inside of each place, right? So if we look at the number, we're checking for all the numbers inside here that meet the criteria of not equal to 0, mod not equal to 0. So if the mod is not equal to 0, what that means is it is odd. So we're looking for all the odd numbers inside here. So 23 will go, 45 will go, 27 will go, and 1 will go. So 23, 45, 27, and 1, so the answer will be C. Because in this case, you're looking at the number. In this one, you're looking at the index. Index here, number here. Next. Alright. Which of the following best defines clock speed? Which of the following best defines clock speed, which is the number of clock cycles that occur within a nanosecond, or the speed at which a microprocessor executes instructions, the speed at which a microprocessor transfers data, number of bits transferred. This one interesting. Clock cycles which occur within a nanosecond. I don't think it occurs within a nanosecond, and I'd never seen that definition before. I know clock speed is the speed at which the microprocessor executes instructions. Yeah, that would be B. I definitely don't think it's nanoseconds. Nanosecond is... might need to double check that. Let's double check that. Yeah, number of instructions that the processor could execute. Yeah, because you can't use nanoseconds because some computers work faster than others, so nanoseconds wouldn't be a measurement across the board. Okay, next question. What output would you expect from the following program? Include stdio.h, int a, b is equal to 5, b is equal to 10. The value of a is %bb, print goodbye. Alright, a is 5, b is 10. The value of a is %db. What's going to happen is that you're going to get whatever values inside B is going to be latched on to that placeholder there, which will be 10. So the value of A is 10. Next line, goodbye. This \n will put this on a new line. So the answer here is A. All right. Oh, that one red. This one real blurry. I'll try, but I don't know if I'll be able to see all of this. This will be kind of plenty. Let me see. Alright, the following. But I can't see that at all, but I believe the answers here looking like x is equal to x plus 1, input y, and y is equal to y plus 1, and x is equal to 5. That's basically what I think I see in there. But I'll try my best. Y is equal to 5, x is equal to 1. While x is less than 10 and x is greater than 0, so that means it's between 0 and 10. Exponent is x and y, so it's going to send the value 1 and 5. The function power raises the first value to the power of the second value, so 5 to returns 5 to the power of 2. So we're going to get 1 to the power of 4. What statement can be placed in line 6 to ensure that the loop terminates? X is equal to x plus 1. Yeah, because it's a while loop and you're using x as your value. x is equal to 0 and x is less than 10, sorry, greater than 0. Yeah, x is equal to x plus 1. So the answer here will be B, because you're checking to see if you're making sure the loop increments. You're making sure the loop increments. That's the important part. Next. Alright, the decode part of the fetch execute cycle. This kind of cakeish. Decode is, alright, when you're executing an operation, you have the opcode and then you have the operand. Right, so the opcode is what the CU is going to look at to decode what is trying to be done. So it could be like add or subtract or whatever it is inside there, right? So the decode part is to determine what the operation is. Yeah, so it'll be B. Right, the operation is linked to the opcode. The operand is where in memory you're trying to find the information, or which part in memory it's supposed to be. Next. This one is what, our error algorithm. Let's go. Alright, the following algorithm is needed to print half the sum of two positive numbers entered by the user. Which line contains an error? Half the sum of two positive integers entered by the user. Where is the error? Read A, read B. Sum is equal to, oh, the error is line 4, because they have sum here in common letters, but the sum up here is capital letters. So the variable names have to be the same. This variable name not matching this variable name here, so the answer will be line 4. Alright, the following statement refers to C programming language. What about the statement do we have to look at? Take all your time, please. Take your time. Alright. A large program is easier to debug if it is composed into a set of functions. When you break up a program up into functions, it's easier to debug because you could check one function at a time. Structures is just to hold the data a particular way. Variables is we use all the time. Objects are for object-oriented programming, but C programming is not object-oriented. C++ is and Java is. Next. Typically, a variable that is declared in a function is accessible within the function only because when you write a function like int add, and then you have whatever, and you have int a inside of it, this a only works inside the bounds of this function here. So it's only in the function only. What else? Questions, and I'm starting to get easier now, but like all you was grasping at straws to find questions for me to answer. These questions are starting to get real simple. Just like the cake questions. Cake. What are the values of A and B after the following code is executed? So A is 10 and B is 25. That's nice. Int temp A. So we create our temp, and temp has the value of A in it. So temp is equal to 10. Come on, behave yourself. Right, so temp is equal to 10. And then B is equal to A, so then B is going to end up becoming what is inside A, which is 10. And then A is going to have what is inside B. A will be 10 too. Yeah. Whatever inside A, which was 10 at the point in time, goes inside B, which is 10. And then whatever inside B goes inside A, which is 10. Yeah. Alright, so A is 10 and 10, and B is 10. Same thing. What is it? Is a combinational circuits question now? Watch me. What is the name of the combinational circuit which converts binary information from encoded inputs to a maximum of 2 to the power of n unique inputs? So you get 2 inputs, and then you get 2 to the power n, which will be 4, 1, 2, 3, 4. That is a encoder. Yeah, that's an encoder. Yeah, so like when you get 0, 0 on the input, so this will choose that one there. When I choose 0, 1, it will choose this one here. 1, 0 will choose this one here, and then 1, 1 will choose that one there. Okay, that's an encoder. Now multiplexer, because multiplexer has a multiplexer does have selection lines, but this don't have any selection lines. It's just 2 inputs, so that's an encoder. A decoder will take 4 and break it down to 2. Alright, let's see. Next is which of the following control structures can be used when attempting to read data from a file where the number of records is not known? Right, so when you're reading from a file and you don't know when you're going to stop, normally just have like things in the file, blah 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 blah, and then they will say they have a X at the end, or a star at the end, or a 0 at the end, or something. This thing here is called a sentinel. Sentinel will tell you that's where we stop. We stop because there is a value that tells us once you read that value, stop. Let me do this one. Which of the following is not an advantage of storage devices over main memory? Which of the following is not an advantage of storage devices over main memory? Storage devices. Okay, the advantages of storage devices over main memory is that they do have a greater response time. Storage devices don't move as fast as memory. So this is not an advantage of storage devices over memory. Less volatility is an advantage, greater probability is an advantage, larger storage capacity is an advantage, but this one is not. So the answer is C, because RAM will definitely move faster than any storage device. Okay, should be winding down now. Which of the following is not a valid identifier for a variable? Well, I think I went through something like this just now. This is not a valid identifier for a variable because you can't start a variable with a number. So the number 2, you can't start it like that. Okay, let's see what else we have here. Which of the following is true about flip-flops? Which of the following are true about flip-flops? Flip-flops are examples of defective logic circuits. No, that is not true. Flip-flops are two-state devices that can store ones and zeros. Yes, registers are made up of flip-flops. Yes. 2 and 3. So the answer will be C. C is good. I remember this guy. This is plenty. Let's see what will happen here. Alright, so we have a diagram. Okay, it says which of the following steps represent a correct sequence of changes that changes the configuration. No, correct sequence that changes the configuration shown in diagram 1 into the configuration in diagram 2. But they give us some rules. They say only variable 1, I'll put the let me just kind of cut this off and I'll put the rules on the left hand side. I can't cut it. Yeah, whatever. I tried. Yeah, that's how to squint. Alright, so we have the rules, which is we could move block A to 1 move, and they have all the different moves that we could do. But it says only one variable can fill a block at a time. So that is rule number 1. A variable can move from a filled block to an empty block. Cool. A variable can move to an empty non-adjacent block, right? So we're trying to get this to look like that. First thing that we have to do is try to get A into here. Can A go inside there? Does it break any of the rules? A variable can only fill one block. A variable can move from a filled block to an empty block. A variable can move to an empty non-adjacent block. So therefore A can move to block 2. That is not valid. What we can do, so because A can move here and C can move there, what we could do is we take B and put it inside there, right? So definitely moving B to block 2 is our answer. Move B to block 2, so that'll be 5 is one of them for sure. And then once we get B inside block 2, that means here will be empty. Then we could get A over to block 4, because C can move to block 4 because it is adjacent. So the only thing we could do is move A to block 4. Moving A to block 4 is 10. But then we don't have a 10 down here, so we have to try to find another move. So instead of moving B to block 4, we have the possibility to move to move A now into block 4. So we could start off by, instead of filling up moving A to block 2, we're moving B to block 2. Well, that's possible. Alright, so B to block 2 is possible. So we're looking for b to block 2, which is 35. A variable can move to an empty non-adjacent block, so you definitely can move to an empty block, but it can't be next to you. So you definitely have to move this B alone, because the A and the C can't go in that empty space there. If we clear out this, that means block 4 going to have a space where the A could go, but moving A to 4 is not an option. Let's think some more, kids. B is adjacent. The only first move that I could make is B going to block 2. That's the only first move you can make. You can't make another first move because A and C are adjacent. A variable can move from a filled block to an empty block. A variable can move so if B goes to block 2, which is number 5, then you'll put A into the only thing you could do is put A into block 4, because C can't go into block 4 because block 4 is adjacent to block 3. And then was 11 moves C to block 4. Let me draw it out. I know I answered this question already, but for some reason it's a little more confusing now. So this is block 1, this is block 2, this is block 3, and this is block 4. As it stands, we have A, C, and B. Our rules say that only one variable could fill a block. That's cool. I can't increase the font size because you won't be able to see the answers. It's impossible, so that's why I'm drawing it. Because you need to be able to see all of this here. There's not much I could do with this question. Because if I zoom in, you'll be missing out another part. Alright. So I have A, B, C, D, right? Good. What I want to do is move this stuff. I'm gonna draw it over. So I'll go in and have 1, 2, 3, 4. Alright. I'm starting off with A, C, and B, and I want it to get to look like A, B, C here, right? That's my goal. The rule said that only one variable could be a block at a time, so that's correct, A, C, B. A variable can move from a filled block to an empty block, which is correct. And then a variable could move to an empty non-adjacent block. That means they can't be next to each other. So if I try to take If I try to take A and put it in here, it will tell me no, that's not possible. Unless adjacent means right after it. Yeah, I feel they mean adjacent in like alphabetical order, because I think in adjacent will be next to it, because obviously C is adjacent to 3 is adjacent to 2 because it's next to it, but I think they mean adjacent going in this direction, because that's the only way that will make sense. Because then now you could take the C and put it inside 2, so you'll end up getting A. Yeah, you'll end up getting A, C, space B, and then you could move the A to then you can move the B there, the B here, so then you'll get A, C, B, blank, and then you're gonna get you take the C and put it across here, so you get A, blank, B, C, and then you move the A across there, which will be A, B, C. Right, so our first move is basically C moving to block 2. So C moving to block 2 is 6. Then we go in with B moving to block 3, which is 8. So 6, 8. Then we go in with C moving to block 4, which is 12. And then we go in with A moving to block 2, which is 4. Do we have a 6, 8, 12, 4? Yeah. Right. So the assumption that we had to make is that when they say adjacent, they mean adjacent going in going in that direction, which is kind of not the definition of adjacent, because adjacent means next to. Just in case you think a line, adjacent, next to or adjoining something else. So what should I put here? A variable can move to an empty non-adjacent block to the left. So a variable can move to an empty block on the left. That's what they should have said. That's my argument, and I'm sticking to it. Alright, that's it there. Ooh, we end off on a bang there. Right, that's it for all the questions. So this is a student that sent me a lot of questions because they were asking me to do multiple choice papers, and I was like, yeah, I did already, and they were like, no, you didn't do all. I was like, alright, no problem, well, compile all the questions that I didn't do and I'll do them for you. And I did them, every single one. It looked like it was about 20 or 30 of them. How much I select there? Yeah, that's a lot. That'll be 1, 2, let me zoom out of the 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 30, yeah. 33 whole questions. The one where I said encoder was incorrect. What? Two to the n is multiplexer. Why is it correct? Why is it incorrect? It can't be a multiplexer because a multiplexer has selection switches too. It's not just going to have inputs. Oh yes, that's true. It'll be a decoder. Yeah, because it'll decode the two inputs to output. Yeah, you are correct. It will be an encoder. An encoder will take the an encoder will take 4 inputs and convert it back down to 2. Yeah, that's correct. That's my bad. Alright, that's it there. So nobody needs any more ComSci multiple choice to be done. Just send them to these videos and they will be okay. They'll be A-okay. I am going to leave now, for I hunger. Thank you very much for your time, and this will be added to the ComSci playlist and we will move on with life. Bye bye. Good fight. Good night. Well, good evening.